In this video, I'm going to explain derivatives of spatial functions. And here the first function is absolute value. And fx is equal to absolute value of gx. If it is, then the derivative is going to be equal to f derivative x is equal to absolute value of gx over gx times g derivative x. Actually, this value can be equal to 1 or minus 1. So plus gx or g derivative x or minus g derivative x. And we are going to decide this plus minus sign with respect to gx when it is greater than 0, when it is less than 0. And like all absolute value questions. And this one important part, second important part here, the corner points. Corner points means when the function is equal to 0, when gx is equal to 0, we are finding the intersection points with the x-axis. And if you remember, for the absolute value, that points are after this point we are going to cutting the function and we are getting the symmetry of it. And this point becomes a corner point, and the derivative is not defined at corner points. So for when gx is equal to 0, there is no derivative. Also, that mentioned here, gx is not equal to 0. Let me explain what the exercise. Now 1 minus x squared we have here, and I'm going to get the derivative of this one. Firstly, I'm finding the 1 minus x squared is equal to 0. And when 1 minus x squared is equal to 0, minus x squared is equal to minus 1, it's going to be, and x squared it's going to be equal to 1. So x is equal to plus and minus 1. It means that x is equal to 1 has no derivative, and x is equal to minus 1, it has no derivative again. So for these points we don't have a derivative. Okay, so no derivative for this point. We are going to try to find the derivative for the other points. F derivative x, I said f derivative x is equal to absolute value of gx over gx. If you remember, it's going to be times g derivative x, which is equal to f derivative x is equal to absolute value of 1 minus x squared over 1 minus x squared times 1 minus x squared derivative is going to be, which is equal to 1 minus x squared. It's going to be equal to 1 absolute value of minus x squared. We're not going to change this part, over 1 minus x squared times 1 minus x squared derivative is equal to 1 derivative is equal to 0, x squared derivative is equal to 2x, so the answer is minus 2x it's going to be. Then I found the f derivative x, and they're asking for f derivative 2 and f derivative 0. So f derivative 2 is equal to 1 minus 2 square in absolute value over 1 minus 2 square times, here the derivative it's going to be equal to minus 2x. That's why minus 2 times 2 directly it should be, and that's equal to f derivative 2 is equal to 1 minus 2 squared. It's going to be equal to 1 minus 4 in absolute value over 1 minus 4, which is equal to minus 3 times minus 4 is going to be, and that's equal to absolute value of minus 3 over minus 3. Absolute value of minus 3 it's equal to 3. That's going to be equal to 3 over minus 3 times minus 4. That's equal to minus 1 times minus 4, and that's equal to 4. So f derivative 2 it must be equal to 4. And now I'm going to find f derivative 0, because there were 3 values. At the beginning I said that for 1 and minus 1 because they are the critical points, and at the critical points these are the, at the same time, this is the corner point at the same time, corner point. That's why at the corner point we don't have derivative. And here f derivative 0, it's going to be equal to 1 minus 0 square, sorry, 1 minus 0 square over 1 minus 0 square. It's going to be times minus 2 times 0, it's going to be, and here this is going to be equal to 0, and this is going to be equal to absolute value of 1 over 1, and times 0, which is equal to 1 times 0, that's equal to 0, it's going to be. So the derivative at 0, it's going to be equal to 0. Derivative f at 2, it's going to be equal to 4. Okay. Now this is the second question, and before starting the question I need to show that there's no derivative here, because x cubed minus 4x squared plus 4x, when we have written like this, this is the gx it's going to be, and it's equal to, at the same time, x times x minus x squared minus 4x plus 4, and at the same time it's equal to x times x squared, x minus 2 squared. When gx is equal to 0, if you remember, that points are corner point, it is called, and when I say gx is equal to 0, which is equal to 0, x times x squared, x minus 2 squared, x1 is equal to 0, and x2 is equal to x minus 2, it must be equal to 0. Here there is no g, and when gx is equal to 0, I wrote that one, and x2 is going to be equal to 2. So this is corner point, this is also corner point, it's going to be. So we don't have derivative at corner points at the beginning, I said. Okay, now derivative of the sine function I'm going to explain here. For the sine function, the slope is, if you remember, the derivative means slope of tangent line, and the slope for the sine function, sine fx, always it is 0, except the point, the critical point. At the critical point we don't have derivative, because if the function is not continuous you cannot find the derivative. Here the function is not continuous, that's why we cannot find derivative at the point, critical point here. And for the sine x, the critical point is 0. So here the summary: f derivative x is equal to 0 if gx is not equal to 0, if the does not exist, the derivative does not exist, if gx is equal to 0. So here the function is, in the exercise given function is x squared minus x. I'm going to check the for this 2 point, it is asking the derivative. The question is asking the derivative. I'm going to check there is here the function, this is the what is written here, gx. Gx is equal to 0 or not for these points. So x squared minus x, if it's equal to 0, this is going to be isolating the common factor. So x times x minus 1, it should be equal to 0, and x is equal to x1 is equal to 0, and x2 is equal to 1. So this is the critical point, and if the critical point here, this is also like that, and no derivative here, and no derivative for 1. What about minus 2? F derivative minus 2, it's going to be equal to 0, because for the values that make the gx function, this function, 0, we don't have derivative. For other values, which is not the root of this expression, which doesn't make this expression 0, for the other values the derivative is equal to 0, it's going to be. Okay. Now find the largest interval on which the function is differentiable. When it says we should find where the function is defined, and for the definition we should leave the critical points out. Which points are out? When x squared minus x minus 6 is equal to 0, the function is not differentiable. So when x squared minus x minus 6 is not equal to 0, I need to check that one. And if you remember, while we were studying about the limits, we studied about the domain. And at domain questions, when these are not equal to, we are going to find firstly the root, then we are going to subtract from all real numbers. It was like this: x minus 3 and plus 2. When you cross the multiply, minus 3x plus 2x is going to be, and the difference is minus 1. So x minus 3 times x plus 2, when it's equal to 0, is not equal to 0, sorry, x minus 3 is not equal to 0, and x plus 2 is not equal to 0. It's going to be x is not equal to 3, and x is not equal to minus 2, it must be. And the result here, real numbers, where the function is differentiable, all real numbers except two values. These values are minus 2 and 3, except this two value, because this two value makes the function here, what is written inside, 0. That's why this value is not differentiable, does not exist. For the other values, the derivative is equal to 0 is going to be. Here for the floor function also we have some simple cases. There are two values for the derivative. The derivative will be equal to 0, because if you remember the floor function, it was going like this. So the function this is, and which is parallel to x-axis, which means the derivative is also, slope is also equal to 0. And here, if the slope is equal to 0, it means that derivative is also 0 for the points, for this point and for this point we are talking. But when the gx is equal to gx element of z, here the critical points here, when gx element of z, we have jumping point. That's why at that point derivative may not exist. And here we are going to find x is equal to 2 and x is equal to 4. Directly I'm going to check what is f2. If f2 is equal to is not element of z, then the derivative is going to be 0. 2 times 2 plus 1 over 3, that's equal to 5 over 3, and 5 over 3 is not element of z, so f derivative 2 is equal to 0, it must be. But for 4 we don't have the same thing, because f derivative f4 is equal to, and 2 times 4 plus 1 over 3, which is equal to 9 over 3, that's equal to 3, and 3 is element of z, so derivative may not exist at 4, at x is equal to 4 is going to be.